Hi guys, welcome back. And this is going to be 10.1. And 10.1 is going to be broken up into three separate videos just to kind of break it into chunks. Chapter 10, as you've seen with stats, it grows in difficulty as we move forward. Chapter 10 is no exception. It is what I would argue the coolest chapter, but also the most difficult chapter. And so we're going to take it in little pieces, step by step. So this is going to be the first part of chapter 10. Or the first part of 3 for 10.1. And to start out, I want to read you a little intro problem. So if you'd like to read along, flip to page 392 in your book. And we're going to start by looking at a problem. So let's say you want to start a pizza franchise. What should you expect to pay for the franchise fee? Franchise fees permit you to use the franchise trade names such as Papa John's, Domino's, etc. The fee usually includes basic training. They help with marketing costs. How do you make the pizzas? A random sample of 50 pizza franchises fees are below. So the idea is, let's say you want to open up a Domino's, which is the best pizza of the pizza chains, in my opinion. Let's say you want to open up one of these in Findlay, Ohio. Well, Domino's Corporation is going to charge you a certain amount of money to open up a Domino's in Findlay. You get to run the show, but you have to pay so much money to run the show in Findlay, Ohio, and bring in the profits, etc. Okay? And what those fees, again, go for, it's going to train you how to make the pizza the Domino's way. It's going to help you market in Findlay, all that good stuff. So here we have 50 samples of different, we could call them Domino's franchising fees. There's a mean of these 50 franchise fees of $16.58 thousand with a standard deviation of $8.11 thousand. So on average of our sample of 50 pizza franchises, it costs them a little over $16,000 in franchising fees. Okay, so given that sample of 50, we'd say, okay, going to take me around $16.5 thousand to get this show on the road in terms of franchising fees that I got to pay Domino's. Well, let's say, because you're not a trust fund baby, you don't have $16.5 thousand. So you're going to go off to the bank and you're going to get a small business loan. The loan officer says, I'm only going to loan you $13,900 because that's the average cost in franchising fees for a pizza business. And at this point, you're going, what? I just looked at a sample the other day in studying up on how I'm going to open this up that says on average, out of 50, the 50 in the study done, that it cost them on average $16.5 thousand. And this guy's telling me it's only $13,900. That's nearly $2,000. That's over $2,000 less than what I need according to the sample of 50 that I looked at the other day. This isn't quite adding up. However, in your loan application package, you are allowing more than $13,900 for the franchise fee. So using the data, the sample of 50 you looked at that said the average cost was $16,500 versus what he's saying, which is $13,900, it's only $13,900. How can you argue that you need more money? Okay? This is the idea of chapter 10. And you saw this in the chapter 10 intro video. You've looked at the traditionally held belief, according to the loan officer, is that it only costs $13,900 in franchising fees to open up a Domino's. But you've looked at some sample data that argues, no, it's higher. It's $16.5 thousand. How can you mathematically argue that the loan officer needs to come up in their loan offering to you? Okay, and this is kind of what we're going to study. This whole broad concept that there's a traditionally held belief that given some sample data, we're scratching our heads going, hey, that's not quite right. It costs more than $13,900 to open up the pizza, or to pay in franchising fees to open up a Domino's. Okay? And we're going to look at in chapter 10, and we're going to intro in 10.1, how do we begin the process of mathematically proving this? How can we articulate that, well, the 16,058, maybe that sample of 50 was just an anomaly, right? They just happened in the sample to get all the pizza franchising fees that were really high. Or are we saying, no, that sample actually represents the broader idea that cost of franchising fees has gone up? Essentially, how do we discern, and that's an anomaly, that sample is, and that just produced a really high average, versus maybe that population traditionally held value isn't quite accurate? And that's what we're going to do here in chapter 10. So with all that in mind, how are we going to kick off the process? Well, let's kick it off by just understanding some terms. Okay? The first term we are going to look at is the null hypothesis. We are going to call that H sub 0, the null hypothesis. And this is the traditionally believed or understood value for the parameter. Okay? So I'll give you a second to pause the video and write this down. This is the null hypothesis is the traditionally held value. Okay? So let's just start by identifying the traditionally held value. Let's look at a couple examples. So let's say we wanted to study the average height of professional male basketball players this year. Okay? The average height 10 years ago was 6'5". So we are going to do a study of, we're trying to figure out the average height of pro basketball players. Okay? And the average height 10 years ago was 6'5". We would probably end up using the null hypothesis that the mean height was 6.5 or 6 feet 5 inches. 6 feet 5 inches. It shouldn't be 6.5. 6 feet 5 inches. This is the traditionally held value. And what we'll eventually get into is testing this, right? We test this by going, okay, 10 years ago, it was known that the average height of a male basketball player in the pros was 6'5". We'll take a sample of pro basketball players this year, get a value, and then test that sample value against the traditionally held population value and say, hey, is that traditionally held population value correct? Is it still true that the average height of a pro male basketball player is 6'5" on average? Another way of looking at a null hypothesis or identifying it would be if a repair shop claims that it takes 25 minutes to install a new muffler on a car, well, then the traditionally held value is mu equals 25 minutes for a study on muffler service performance. You can also think about this with oil change. Ton of places in Finley, if you go to get your oil changed there, they'll say, hey, it takes 60 minutes. Okay? What's your null hypothesis, your traditionally held value? 60 minutes. And again, this is slightly different than what we did in Chapter 9. Chapter 9, we said we have no idea what the population value is. We're going to estimate it. What we're saying in Chapter 10 is we have a traditionally held value for the population parameter. Is that accurate? We're making a decision about a belief about the population parameter, not estimating it. Okay? Again, the broad concept is no, technically we don't know the population value at this minute, right? Even though 10 years ago the population average height for male basketball players was 6'5". This year the population value, we have no idea what it is. We are just going to assume that it's still 6'5" and then see if the data we come up with tells us, hey, maybe that isn't quite right. Okay, so that's kind of the idea. If you want to talk more with me about that, feel free to do so, contact me, etc. Well, if we have a null hypothesis, the traditionally held belief, what we are also going to have is the alternative hypothesis. And these two are like siblings in middle school. They do not get along, okay? We will label it H sub A. I'll put it here to the right. You will also see your alternate hypothesis labeled as H sub 1, depending on the text or article or whatever you're reading. They mean the same thing. And the idea with the alternate hypothesis is that any hypothesis that differs from the null hypothesis. Any hypothesis that differs from the null is going to be considered the alternate hypothesis. Okay, so make sure you write that definition down. Pause the video, do that, and then let's look at some examples. So if we believe that the modern male basketball player is taller than the average from 10 years ago, the null hypothesis would be, as we said earlier, mu, our population mean, equals 6.5. Our alternate hypothesis is going to be H of A sub A is our mu is greater than 6.5. Our traditionally held understanding from 10 years ago was that the average pro basketball player is 6'5". But maybe we do a study of 50 basketball players and it turns out in our study, the average height was 6'8". What we may come back with is saying, I don't think that traditionally held belief of 6'5" is quite right. I actually think the modern pro male basketball player on average is taller than 6'5". The taller than 6'5" is the alternate hypothesis. It is opposite. It is the different than the traditional belief. Okay? So here's what you practically need to be able to do at this point. I hope you kind of gather the general concept of what we're going to be talking about in Chapter 10. This idea that there are traditionally held beliefs for population parameters, and depending on certain sample data, we might not always believe that traditionally held value. We might question it, okay? Chapter 9, we estimated population values. Chapter 10, we have a traditionally held value. We don't know the current value, but we're assuming that the traditional value is still applicable. But we get some sample data that makes us scratch our heads and go, hey, maybe that traditional held data isn't quite accurate. Okay? And in Chapter 10, we're going to be testing that. So I want you to get that, and I also want you to get what is the difference. How do I identify a null and an alternate hypothesis? So let's look at two examples of it here. A car manufacturer advertises that its new subcompact model gets 47 miles per gallon. We're going to call mu the mean of the gas mileage distribution for these cars. The average gas mileage they get. You assume that the dealer might be overrating the gas mileage of the vehicle. What I want you to do is identify the null and the alternate hypothesis. So take a second, go ahead and identify the null and the alternate hypothesis. Well, in this case, a car manufacturer is advertising that its new subcompact model gets 47 miles to the gallon. In other words, the car manufacturer is putting out there, hey, we believe our car gets 47 miles to the gallon. That is the null hypothesis. On average, right, because they understand that maybe not every single model gets 47 miles a gallon. Maybe one gets 46.6. Maybe one gets 48. On average, you're getting 47 miles to the gallon if you get the new subcompact model. Okay? But you think that the dealer might be overrating the gas mileage of the vehicle. So what is your alternate hypothesis? You think that the gas mileage is less than 47 miles to the gallon. And you've seen this in car advertisements, right? A selling point of cars is that you're going to get a really good gas mileage, right? You don't have to go to the pump as often. You're saving money because for every gallon of gas, you're maximizing how many miles you can drive. But in this case, even though the dealer is advertising, hey, we get 47 a gallon, you think hold on a second, I think that might be a little high. I think in all reality, the average gas mileage of these vehicles might be less than 47 miles to the gallon. Okay, let's look at another example, identifying the null and the alternate hypothesis. A company manufactures ball bearings for precision machines. The average diameter of a certain type of ball bearing should be 6 millimeters. To check that the average diameter is correct, the company is formulating a statistical test. Okay, so what would be the null hypothesis and what would be the alternate hypothesis? Well, the null hypothesis is the traditionally held value. Okay, we believe that the average diameter of the ball bearing, it needs to be 6 millimeters. Okay, we need that ball bearing to be 6 millimeters. But the company is going, just to make sure that what we're manufacturing is correct, let's run a statistical test. Let's make sure that on average, the ball bearing is 6 millimeters. Okay? Well, if on average, they want the diameter of the ball bearing to be 6 millimeters, what would the alternate be? The alternate would be, well, it's not 6 millimeters. Okay, and you'll notice this is different from the last one. And a lot of hypothesis testing, you're going to have to do some interpreting as you set up your null and your alternate hypothesis. You see, in the last problem, they were saying, hey, we're getting 47 a gallon. And you go, wait, it's probably less than 47 a gallon. In this case, though, we're saying, hey, the average is 6 millimeters. But there's no indication as to whether it's on the high side or on the low side, right? It's just we think it's 6 millimeters, and it needs to be 6 millimeters for these machines to run well. Therefore, the alternate would be it's not 6 millimeters, right? If there's no indication as to whether we think the traditionally held belief is erring on the high side or the low side, you're probably going to be looking at an alternate hypothesis of just a sheer not equal to. Again, it was pretty obvious that our alternate hypothesis in the previous example was, hold on a second, we think it's less than 47 miles a gallon. But in this case, when they're just saying on average the diameter of the ball bearing is 6 millimeters, well, what we're going to say is, you know what, the alternate maybe it's not 6 millimeters. Okay, so to summarize, to kind of close out, what do you need to know? Well, when we don't know the actual value of the parameter and want to make a decision about it, we're going to do hypothesis testing. When we say we don't know the actual value of the parameter, it doesn't mean we don't have an idea, right? We do have a traditionally held belief. We just don't know if that belief applies to right now. We knew the population or the average height of NBA players 10 years ago. We don't know what it is at this moment. And so we're going to assume that traditionally held belief is true and take some sample data, some statistics, and see if the traditionally held belief and the data we're getting line up. Okay? That traditionally held belief is called the null hypothesis, and the alternative belief to what is traditionally accepted is the alternative hypothesis. And with that alternative hypothesis, you can have three options, right? If you think about the NBA example, right? 10 years ago, it was understood that the average height was 6'5". We're saying maybe based on some sample data, hey, maybe it's a little higher. We saw with the gas mileage, they are advertising you get 47 to a gallon. That's the traditionally held belief. We're saying maybe it's a little lower. Or with the ball bearings, when they're saying on average a ball bearing is 6 millimeters, the alternative would be, well, it's just not 6 millimeters, since you could run into some problems either way. Guys, thanks for watching. Hopefully you are walking away understanding what a null and alternate hypothesis is, and we'll jump back into this in the next video.